Yeah, introducing Mr. Sawant. He has completed his production engineering from Pune University. He holds an MBA from the Flame University, Pune. He has 9 years of extensive experience in managing large-scale manufacturing projects across multiple industries such as manufacturing, information technology, and telecommunication. He is a certified project management professional from PMI USA with a strong expertise in project management and resource management. Over the years, he has successfully managed diverse project profiles for many reputed clients. Over to you.
Thank you. Thanks a lot. Hi, everyone. Good afternoon. So my name is Suyog Sawant. On behalf of Suyog Hydrosystems, which is owned by my father, I'm presenting uh, this presentation to you. So recently, we developed the AI-powered cost prediction for hydraulic power packs. As in, whenever you want to have the quotation of any hydraulic circuit, that what would be the piping quote or what would be the piping or fabrication quote, you have to manually count the pipes, count the fittings. So there's a solution for this which we have come up to. So Suyog Hydro Systems is a 40-year-old company extensively managing projects which are only in hydraulic power packs, integrating them. And the major customers of ours is 80% business comes from companies like Danfoss Vickers and Parker Hannifin. So we are authorized system integrator for those two companies, and uh, rest of the customers are Tata projects or even Ador or Bharat Forge. So we are authorized system suppliers for them. Yes. Basically, let's first understand the how the costing of hydraulic power pack is important in any manufacturing project. So hydraulic power packs are very essential in all process plants such as cement or steel processing plants. So many of the big projects which happens in these plants are having hydraulic power packs as their main part. So for example, projects like chain tensioning, projects like hydro turbine control, or projects like wagon tippler. So these have basically hydraulic power pack as a main part of the project. So a lot of the manufacturing project costs depend on the hydraulic power pack costing. And effective scheduling of these projects, managing their resource, taking out the POs on time requires lot of cost estimation, and majorly it depends on the hydraulic power pack. And so accurate HPU costing often plays very important role. Otherwise, it cost variance in the whole project, and that takes a lot of time. So this is the significance of hydraulic power unit costing. And the major cost in any hydraulic power pack is piping and fabrication, if you see it from the manufacturing perspective. So traditional methods of calculating these piping and fabrication costs are to manually count the pipings and manually count the fittings and then calculate the cost. So that takes a lot of time, and it also has human factor, so it causes the manual error also, that I might have missed this fitting, or this fitting is not calculated while quoting. So what happens at the time of project execution, many missed out fittings are having delivery times such as 3-4 weeks, and that delays the whole project. So this is very crucial to calculate the fitting at the right time with the right cost. It is oftenly this costing is depends on the third-party integrators like us, or the authorized integrators or the subcontractors who are highly experienced in calculating these costs. So, but these are again from the OEM's perspective. Again, these costs are uh, or external or dependent on the external factors. So many HPU OEMs like Danfoss or Vickers have their parts cost ready, but where they struggle a lot is to calculate these costs, because again these costs plays major role in negotiation, in finalizing the POs, and also to accurately quote the project. So this is our solution. So this first I had submitted this as a paper, then recently for the last times, and after 3-4 months I developed this tool only. Though this is currently a web-based tool. So this is our solution. This is a AI-powered tool developed by us. So the tool has a process that you can give any circuit, hydraulic circuit, as an input to the system. And it's a web-based tool currently developed on Python. And then it takes the input as a PDF tool of hydraulic circuit, and then it generates the Excel-based CSV format piping BOM. So this AI-generated BOM does not only provide you the accurate costing, but it also gives you the fittings and the listing, which you can then send across to the multiple supplier for procuring the hydraulic fittings and the pipes. So it has a complete solution for the backend as well. So the same BOM can be shared with suppliers for stock checks and the delivery processing, enabling a complete seamless supply chain solution. This approach also saves a lot of time because you just have to put the PDF, and then the AI and the tool counts the fitting, and then it gives you the CSV generated BOM in a minute, less than a minute. So it is very fast. It has around 90% plus accuracy when we tried with our model. And it also enables digitalization for MSMEs for standardizing costing. So this is how the app works currently. So I have the web-based app, which is not hosted as of now. I have not deployed it. It is currently just with me because there are many. We are just about training more models and optimizing the tool. So this is how it works. First is the user interface, where we get to see how the app looks. I've got the picture for it later. And then file handling, where you give the PDF of the hydraulic circuit. Then the PDF goes to the system with the Python reading library, and it uses OCR. So OCR is the same technology. When you click a photo, you can now select the text out of it. So OCR is optical character recognition. So when you give the PDF to the system, it detects all the text in it and it copies it. So whenever the hydraulic circuit has the piping description or the fitting description, it copies that, and then there's a separate library for in Python for this, and then the recognition engines then identifies the pipe, detects the fittings, recognize the walls and filters, and tank specifications and tank sockets and accessories. So there's a rule-based logic in this. So whenever there is a standard pipe of, let's say, 16 mm OD by 2 mm thickness, so the system, if the end fittings are not given in the circuit, the system used rule-based logic, and whenever there's a 16 mm OD pipe, it automatically chooses 16 into half-inch male stud coupling at both the end. So this is how it works. So many of such rule-based logic is given to the system by me. So there are logics like when there's a T section of pipe, so you have to take consideration of single T coupling. So it has a rule-based logic for that. Again, when there is a 20 mm OD pipe and it is going to the tank, so it automatically takes 20 into 3/4 as a male stud coupling, and plus 20 mm OD pipe, so suitable 1 inch or 3/4 inch socket into the consideration. So it has got all such types of rules enabled in it, and you can have the logic in it. So the same flow path is here. So from recognition engine, it goes to the BOM generator, where you have the list of all the components which are required in the piping. So such as male stud coupling or sockets or pipes, everything at one place. You have the part codes also, and the quantity is also added because the system counts the quantity, and this is where we are getting benefited. And then the live costing is added with the partner's supply chain. So what we are doing is, from the back end, we will be contacting, or we will be communicating with few of the piping and fitting supplier, whom we can give this user as a lead that this person might need your fittings in the future because he has searched for it, he has taken down he has used the tool and he has taken down the list of fittings. So that same person will calculate the user, and also the user will get the live pricing integrated by us in the backend. So it will have a complete solution for procuring the pipe and fittings. So output will be Excel BOM, PDF code, and also the screen will show that this much fittings is needed, and this should be your piping code. So the conclusion was this. Conclusion is this: trials conducted with developed AI-powered costing tool used as a hydraulic circuit as an input, and gave away Excel-based BOM as output. It achieved 95% accuracy when we tried with 2 or 3 circuits, and it is still under training, so it will have more efficiency after training the model or fine-tuning the model. The generated BOM can directly share with supplier for pipe and fitting orders, enabling faster and more reliable order processing. So this was firstly I presented as a paper last time, but meanwhile I had the time, so we developed the app itself. So now it's a working model now. We have even tried with this. So currently this is how my tool looks like. So this is the place where you have to put the PDF, and once the PDF gets inside, the Python then calculates the fittings in it, and then it generates the Excel BOM. So this was the working example. You can see, just give me a minute. So you can see there are 16 mm OD pipes here, 1, 2, 3, 4, 5, 6. So like this, there are a few 16 mm OD pipes here as well, some 12 mm OD. And this is a basic, very small circuit I've taken just for example to show us how it works. So this is the circuit. If you try to calculate it manually, it might take 5-10 minutes, but with our tool, you can just calculate even less than a minute. And this is the output, which I got right now. So it has a list of all the fittings that this is the tube couplings that you might need for this project. Total 20 mm 3/4, you will need 6 quantity. This is 200 rupees is the live price, and like this, the total fitting cost is 5,090. And currently, how we are using the logic as it is counting the pipe and into multiplying by 1 meter, because currently you are just giving circuit as an input, so there's no general arrangement drawing, so it cannot detect how long the pipe is needed. So there might be the case that manifold block is here and the termination is right here just for the customer convenience. So you might require 3 or 4 meters extra pipe. So that facility currently is not there in this version. So you can manually add that into this Excel here. It is right now calculating based on the number of counts. So 16 mm OD, there is 8 counts. So like this, if you can see 1, 2, 3, 4, 5, 6, 7, and there should be one more. Yeah, this is the 8th one. So this is how it is calculating right now. So 280 rupees is the plain price right now of the pipe, 16 mm OD. And it is detecting the grade as well from the hydraulic circuit. So the same can be shared to the supplier. This sheet will be a lead sheet or the sales prospect sheet for the fittings and piping suppliers, and the same is for the PR processing or the purchase order processing for the user. So, so this is the typical costing is coming, material costing. Then we have multiplied by per meter labor, and this should be the actual cost. So you'll get this within few seconds as an output. Currently, it is just detecting the total tank capacity. I have not enabled it to give the overall size of the tank that I can do, the standard 250 liters tank that you should take 400 mm width or 600 mm length on 400 mm height, something like this. But I have not enabled it right now. So currently, this is the output which we are getting. Yes, this is the complete supply chain solution which I have proposed. And the later version of this, which I'm working on right now, is you can then, in our future version, you can add the general arrangement drawing into the system, and then the OCR will detect the size of the square tubes needed, the ISMC channels, and the angle, and it will calculate the fabrication cost as well. So later, if there's a 150 liters tank, the standard 150 liters tank costing will be also given, and the one from the GA, that GA shows 400, 500, and 300 mm as a tank dimensions. So this is the cost. So that I'm right now working on. So once you can have the GA drawing inside, it will automatically give you the fabrication cost and also the piping and the integration cost. So you will have the complete faster costing process with respect to hydraulic power packs. Yes, so later, currently this app, which I have shown you, is currently on the local host. Just with me, I have not deployed it anywhere. So I'm thinking of doing this as a software as a service, kind of 300 rupees or 500 rupees per pay per usage, or could be collaborated with any of the major OEM. So this is the vision for it, and it will have the local tokenized login credential. Tokenized login credential, as in it will have the OTP wise. When you will have the phone number entered, then it will verify your purchase that you already have our subscription. You can use it for free. Otherwise, there's a pay per use model. So this is about it. And yes, thank you. Thanks a lot.
Thank you, Mr. Sawant, for a nice presentation. Cost and delivery is one of the critical deciding factor of every industry's business. So you are touching on that very well using the AI. Your model, the piping is and fittings are major
Yes,
output.
yes.
So what is the percentage of piping cost in overall power pack?
So, sir, actually, it varies a lot. I mean, it could be for a crore, for a 1 CR price point of power pack, it might go around 6-7 lakhs of piping costing as well. But for smaller one, the action should be very quick. I mean, even if it's for 20-30 lakhs power unit, the costing part should be done very, otherwise it will take, because in OEMs or even company like us, only 1 or 2 people can figure out the costing. So it takes a lot of time. If such tools are used, it will be standardized. So that was.
Other clarification is generally the hydraulic circuit, the pipe lining will be show straight lines. But in the practically site condition, pipe will undergo the routing.
Yes.
A lot of bends will be there. Every bends create a cost. The
Yes.
CNC bending, all those things. How we are
So
how we are using AI
currently,
for that?
so that's the reason I have put it in Excel right now. So you can manually add the length of the pipe as in this version. So which
But as a output, it doesn't come with those bend as a cost factor.
yes, so like this. So you have to see the GA right now, and you have to add the length of the pipe. Otherwise, in future, which I'm working on right now, is you are going to give the general arrangement drawing to the system, and then it will analyze that the termination of 16 mmOD is going here, and the overall length and the drawing size of the power pack is this much. So you might need this much pipe. So that is still under the.
No, my question is not on the pipe size. Anyway, that is given length,
Yes, yes.
diameter given,
Yes,
pipe
yes.
length is there. The cost is not related directly a pipe length and a diameter.
Okay.
It depends on how many bends,
How
depends
many
on the
bends,
site
yes.
condition you have to routing.
Yes, yes.
Pipe routing will be there.
Yes, so that factor is there, that it could be the case that some pipe is not getting fit with my normal elbow, so you have to add the swell elbow, which adds around 20-30% of the costing here. But right now also, sir, if you are in a quotation phase, you have to consider these things, that this would be the additional cost. So I'm just behind that thing, that while quotation purpose or while planning for the project, the process should be faster. So there will be some requirements of special fittings in every pipe. Yes,
I
I
thought
got
that is
your.
a critical factor because some of the bend to be done in the CNC machine only. Some
Okay.
can be done manually. Then cost factors will be
Yes,
different.
yes. That is a good point. I'll think about it and I'll try to add it somewhere. Yes, thank you.
Normally, when we think of AI in the manufacturing industry, we think of robots and, so it's very nice that you have thought about
Yes,
taking care of the desk job.
Yes.
But again, like what he was speaking about, I think what is very important is the routing. So that's where significantly you could apply AI there.
Yes.
So I would personally recommend that
Somewhere. Yes.
don't launch this yet. Get that feature
Yes,
in
I'll
because
add
that
it.
feature is the most useful.
Perfect,
But I can see you have done great amount of work. Congratulations.
Yes. Thanks a lot. Yeah.
Hi, so I have a question here at the back. Here.
Oh, yes.
So, so can you go back to the slide where you have presented the flow chart?
Yes.
Yes, exactly. So the input is a PDF, and then you're trying to use the image, and then you use OpenCV OCR libraries, right?
Yeah.
So I want to understand what kind of challenges you faced, because while driving similar projects, there is a lot of hallucination in identifying the wrong components. What kind of fine-tuning you have done, what challenges you faced, and how did you overcome them?
So in Python, we have the OCR library present, which carries out all the extraction of the written elements. So I have added the logic such as there's a line below the number is written, it will be identified as a tube size. So this is the logic behind that. And the OCR library works well on the both image and the PDF. So this is how it works.
So it works purely based on the text that is written
Text
on the drawing.
that is written, and the logic behind that is if the tube, how that the system identifies it's a tube. So that's where the AI agent come, because otherwise it just, Python can just extract the text. But text into something, I mean the thickness is written, that identifies as a pipe size. So this is how the logic is given.
Okay,
Yeah.
thank you.
I have one question.
Yeah, please.
It's not a question, it's a comment. Is this app, is it possible for the app to throw, these are the errors? Is it throwing any errors, or these are few things which is not clear, so I am not able to make an estimate?
No, actually, it doesn't have that right now. Why I'm telling you, so probably many of the, it is still in the very early phase. So I'll just give you an example. For example, written line filter generally has a 1 inch or 1.5 inch SAE flange, for example. So right now with written line filter, if it is a 30 mmOD or 42 mmOD pipe, it is directly taking 30 into 1.5 inch male stud coupling as an end fitting, because I've given such rule to it. But why I've not bothered about it, why it is not selecting the accurate SAE size, because I'm not entering the BOM right now. So once we can take this BOM as an input, it can then extract the BOM. Written line filter would be, so for example, TIF from hydro line. It will go to the manual, it will check the end fittings, and then it will add it. So right now I've kept it very crisp, because I'm alone to make this, and it takes a lot of time. So such questions, and I'm noting down. So that was the reason I wanted to present it here. Something like routing or something like end fitting. So these are very valid inputs. Yes.
So there is also a possibility that, no.
Okay, no problem. Okay.
Just one point before you leave. I'm Seshnath here.
Yeah.
On a lighter note, don't ever give a token to OEMs like Bull Machines here, because otherwise all the component manufacturers will have to shut shop.
Yes. No, all good. I understood the point. Perfect. But
So
there are plenty of such ideas are going into mind. I thought I'll just at least take one. Let's see where it goes. And the main thing is we are a very small company. We have got 14, 15 laborers and few employees inside. My father is into 60. Still, he handles all the business. So we were just executing company. So whenever I get time, I try such things, and this is how it comes.
It's a great
Yes, thank you.
initiative, I would say. I run a similar company, and this has been a challenge all through.
Yes.
I keep training people on this. So absolutely, very positive on it.
Thank you.
One small thing that you could add on, because half the time people make a mistake on the pipe size.
Yes.
So which is, if you could just enter the pump flow rate,
Yes.
and let the app decide the
Manometer wise, we can add that. Perfect.
speed
Good as an
and
input.
like
Yes.
return line, T line, I mean whether it's a return line or
Pressure.
a suction line or a pressure line, and let the app decide the diameter of the pipe. And
Yes. So this was just as an example. If we don't have this as a BOM, and if we could have just given the BOM without the details on the pipes given, you just have this this flow rate and the pressure, then it automatically detects the size as per the logic behind the manometer, I mean with the graph. So right now it has the information written on the pipes, that's why it is detecting the same. Perfect.
Suyog, I have a question.
Time is running out.
Yeah.
Though it is interesting subject, we have to go forward.
No,
I have one question, if
it's
you
all,
can
like with
allow
all
me.
things AI, I mean, just my
Yes,
input.
please,
With
please.
all things AI that we are using right now, now you are depending largely on the schematic drawing being accurate,
Yes.
right? So I think that you are that in between link in between getting the accurate diagram to begin with and then providing that service towards the other side, which so many AI give us so far. So that is a challenge often we face, that the input that you're giving, is it right? To get the right output. Now, we are assuming that all of that is right. So I think if you can get that equation between getting the right information and giving the right output, you're like bang on then.
Perfect, perfect. Thank you. So basically, let me just reiterate again. So idea behind this was, so even if the project doesn't come to us, many a times we have to make, I mean, generally the conversion percentage is very horrible. I mean, I quote for 10 or 12 systems and then one system comes to it. Still, at my age, I don't say no to the customer. I manually used to calculate the fittings and the pipings and then used to give it to the OEMs. So this is where I thought of making this. So yes, you're right. The circuit validation should be there. But currently, I mean, the quotation the quotation process is also very time delaying and depending on the external factors like subcontracting or third party integration, something like this. So that's where I thought of making this. Perfect, perfect. Thank you.
Fantastic effort.
Yeah, thank you. Thanks a lot.
Oh, sorry. Yes, Mr. Sheshnath, can you do the orders again? Please, can you just wait? Yeah.